All right, here we go. So we've got C, what is it? 2 cos squared x minus cos minus 1. So it's just creating more, not issues, but it's just trying to be harder than it really needs to be. So the tip that we gave you last lesson was that replace the causes with x. So if we did that and we had 2x squared minus x take 1, could you factorize that? I mean, and you could go to your calculator, as we said, if you really wanted to, but everything's prime here. So before I go to the calc, I'm going to give it a crack. And we can see that, ooh, to get a minus, wouldn't that have to be minus 1 there? Because 2x times minus 1 gives you minus 2x. And then that would have to be plus. Minus 2x plus 1 gives you minus x. And double check, positive times negative. Yeah, baby. Right, so we're going to apply that now to our cosine 1 over here, which means this would be 2 instead of x. It's going to be 2 cos x plus 1 and cos x take 1. Now the whole point of this, the fact that we factorise, we've got now 2 questions in one. Because what we want to do is we want to make sure that 2 cos x plus 1 equals 0. And now we can solve that, so that will put the 1 on the other side. It's a minus, divide by 2. So we're solving now for cos x equals minus a half. And then this one, we're looking at when cos x equals positive 1. Yes? Do I have to continue? We are happy that we can find when cos is, Lisa, when it's minus 1, minus a half. This one, I got to say, how do you do? Do you just know that one? Cos x equals 1? I got to say I'm a visualizer, so I would have to think of, so 0 and 2 pi. Yeah, I know, but how do you just remember it? Because Deb just said, isn't that just every 0? Do you remember it with the graph, or do you remember with the unit circle, or you just remember it? Yeah, you find unit circle easy. Interesting. Good. Good. I'm just graph. I don't know why, but anyway. Okay. So, shall we try D? Or do you think you could use what we just suggested with the x's and try that one? I think for D we'd be okay. Now E, a little bit of an issue. So E and F. Right? Because, do you agree with me? D is just going to be the same. Yep. Okay. The issue with E and F. Right? Yeah, we've got a sine, we've got a cos. What shall we do? Great suggestion. So, got to do something. So, yes, the suggestion was at least get everything on one side. I'm happy with that. So, with E, and this is a little bit sneaky. It is at the end of the chapter. And so if we sort of did this in order, you'd be much more confident with what we're about to do. But it's okay. We still have seen this thing here. So what we want to do, and sorry, I'll just bring everything. Shall I bring it? Actually, I won't bring it on one side yet. We want it all to be sine or all to be cosine, right? You have come across a situation where sine squared and cos squared have a relationship. They're linked together. Yeah, Deb. That's right. Sine squared plus cos squared equals 1. Where did we see that before? That is indeed from the unit circle, right? Crazy important identity there. So what we could do with that, anyone?
We could just add cosine x on both sides. What does it bring to the other side?
Dev is saying stuff, which I don't quite understand, but what can I replace sine squared x with? So can we rearrange? Yeah, thanks. 1 minus cos squared. So now I can replace that here. So this is now going to be, instead of sine squared, it's going to be 1 minus cos squared equals 2 minus cos x. And now we take Dev's thing about getting everything on one side. And which side would you pick? Why? He said right side. Why? I would too, just to make the thing that's squared positive. It's just easier if that's positive, okay? So we're going to go 0. That becomes cos squared x. I've still got my minus cos x plus 1. Ooh, that's a bit nasty. Is that right? If you didn't have your graphics calculator, how could you do a quick check for no solution? Instead of the whole instead of the whole quad formula, you could just go discriminant, b squared minus 4ac. If you get a negative answer, straight away you've gone boom. No solution here. Does that make sense, peeps? Okay. What do we propose to do with this one? Once again, they're two different trig functions. Yep. Isn't cot 1 over 10? I agree with you. So shall we mess around with that one? So we've got 3 tan x equals 1 over tan x. And now what? Dip. Let's multiply up by 10. So we've got 3 tan. Now, we talked about this, I think, last term, but tan x all squared, we don't want to write it like that. That's just nuts. We write this as tan squared x. Okay? Do not, right, that is not the same as tan x squared. If you leave your brackets out, you've got a different thing. So notation, 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 okay? Because what's this doing? It's only squaring the x value. So please don't be sloppy with your work. So we've got tan squared x equals 1. What will you do now? Get it on one side. So tan squared x equals 1 on 3. Now that's not one of the ones from our checklist, but that's okay because we haven't got tan x yet, have we? How do I get tan by itself? That's right. So if you just keep repeating the same processes that we're going through, so now to get rid of the squared, we're going to square root. Am I good with that? No, good. What am I missing? Excellent. Remember, when you are square rooting, you have a plus or a minus answer. So if you forgot that, because we talked about it last lesson, you might want to write yourself a little bit of a note to remind you, because if you don't think about the negative values, what's happening with the number of solutions? It's decreasing. You're actually going to miss out on half of your solutions, possibly. So please make sure that you do your thing, because now your working angle, you find that, and it's going to be in all 4 quadrants. Not very symmetrical there, but anyway, I was bending down. Okay, so saw this in methods because we know about our trig graphs. We should have seen this before as well. A affects the amplitude, right? B is your period. C is your horizontal translation. D is your vertical, moving up, moving down. Okay, if we can find most of these, we should be able to then get the equation of our graph. Sweet? Pretty basic situation. Again, you did these last time. To find your altitude, I should have said amplitude there. Typo, righto, a writer. God knows what I was thinking at the time. Maybe taking off on a plane. Anyway, you get your maximum, your minimum, subtract, divide by 2, bang, you will get your amplitude. The principal axis, that is your D value. Okay, so that's this thing that goes all the way through. That's the average of your max and min. So add together, divide by 2, you get. Simple so far? Then we want to find the period. Now we know the period when it's we want all of this to be a sine function. We want to write it as a sine graph. It's 2 pi on B, so we check the graph and we see how long does it take us to complete one circuit. Okay, so if we're looking at this one, Seb, are you playing with us? Doesn't look like it, right? It's pi. So the wavelength, the period, it takes pi. So then pi equals 2 pi on b. You can find b, it's 2, and away you go. Okay? Yes. And why is the c value non-existent? Because when we look at our principal axis here, it starts here, it's y equals 1, boom, it's right here at 0. So c is 0, okay? And that's the difference probably from what we did in methods to what we're doing in spec, is that in methods we didn't really have too much of a translation, or horizontal. If we did, it was very obvious. Now, what might happen is you have to make sure that you pop in. So I would draw in your principal axis, and it's where your c value will be where the function is increasing at the first point. I don't want to do it for you, but so as an example here, when I do I draw my principal axis in, you can see that it would be around here. Can you see that? So that would mean, pi on 6 is my translation. See how you go. And it always has to be when it's increasing. So that's okay. I didn't find one where it was never. Anyway, so could you please read, have a shot. Solutions, as in the final solution, is on on OneNote, so you could have a look. And if you're stuck, then I'll come and help you individually. How's that sound? So we're not going to take too long to do that, because then we're going to show you how your calculator can do it as well. Yep, no, that's fine. I forget sometimes too, so we'll just go through it again. Shall we do the same color code? Yes, we shall. All right, so A, what's my max?
0.
So I've got max equals 0, min -4. So according to our thing up there, we're saying this is going to be max take min, divide by 2. So it's 0 take 4. And you think, oh geez, that was pretty obvious that we could see that the amplitude here was indeed 2. So, but we're proving it, okay? And then to find our d value, our principal axis, we are now saying it's max plus min all over 2. So 0 plus -4 all over 2, we get -2. Happy so far? What have we got? We've got y equals 2 so far. Take 2, right? We now check for the period. So we look, how long does it take to complete one wavelength from start to here, and then it repeats 2 pi. So what's my b value then?
2.
No,
Well,
1. Okay, so I'll just show you though, but we'll say again. So to get your b value, that means the period is 2 pi over b. We're saying our period is 2 pi because that's how long it takes to complete one lap. And therefore b equals 1. Happy days?
Yes.
We have a look at where our principal axis is going all the way here, and because it's starting at 0, that's telling me there is no horizontal translation. Boom. So, I mean, you actually did these ones in methods, so all of them will not have they all have a horizontal translation of zip for that first page. It's over the page where you can get stuck in. All right? There is one on the bottom. Okay. Some people were just saying this one it's saying it's got a horizontal translation of pi on 3. Now, I disagree with that. It is not saying that at all. It is saying that it's sine 2x take pi on 3, but remember, we said that to do the horizontal translation, it has to be in the form b x take c plus d, right? That is not in that form. Okay, so this, to put it in that form, is a simple matter of pull out your common factor of 2. It will be x, Now, 2 times what gives you pi on 3? Guess what? Pi on 6. Okay? So you do need to be careful of that, because your calculator in a minute, when we ask it to give you the model, the equation, it will actually write it like this. And as you can see, using FX Draw, they've also written it like that. You could check on your graphics calculators if you wanted to. You could type in both of these and you'll see that it's the same graph, one on top of the other. If you typed in, obviously, 2x take pi on 3, then it's not going to give you the same graph. It's going to move it further along. Don't think I'm going to spend too much time on this at all. We're not going to get you to graph these by hand, Ollie, we right? You wouldn't be graphing these by hand unless I really wanted to kill some time in a test, which is never the way. But you can see, so periodic functions are things that have a cycle to them that repeat, right? So things like the tidal waves, tide goes up, goes down, goes up, goes down. Okay, things that move around in a circle. So the height of a Ferris wheel. You've got a cage on a Ferris wheel going around and around. It goes up and then it comes down and it goes up again. And we've seen that. That's how we get our sine and our cosine rules, from traveling around a circle, correct? Temperature tends to be a cycle, although these days with climate change, I think that might now not be a great example anymore. But anyway, imagine that it is cyclic, okay? So we would like to get a model that predicts this. And they're asking you, some of the questions here, they ask you to do exactly what you have just been doing with the graph. But obviously the downside is that you had to sketch it first from the points. And we go, who wants to do that? Boo. So could you grab those graphic calculators, please? To the stats mode. Okay, now I've got something in my stats mode because I've used it before. Do you have anything in yours?
Yes.
All right, so if you do, what have you got? Nice. All right, so we go over here. Right, at the bottom, I'm going to use my arrow keys to go more, and then I'm going to say delete all. So, and I have to be in that list. Do I really want to delete it? Yes, F1. I move over my cursor to list 2. I say delete all again. And because sometimes I get students to scroll down, oops, no, enter, 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 and just put something right at the bottom. So it's best to just delete everything. All right, we use our arrow keys to get back, so everybody's got that down here, right? They tell you in the question, make January number 1. So we're going to go 1, enter, 2, enter, 3, enter, all the way up to 12. Okay, and then in list 2 we are going to put the temperatures, so 28, 27. We just want to graph this, and by the way, this is working when we've got a whole lot of points. You could get this, remember when we were trying to find the equation of cubics? So all you need is 3 points. You could put it in here, list 1 be the x values, list y be the y values, and it would give you the equation of your cubic. Same with the quadratic. With a quad, you probably need 3 points as well. Anyway, so we're going to go to graph. So we press graph. But before we actually say graph 1, we have to check that the graph is set properly. So go to set. Scatter is the one that we want. Okay, I was in list 1, list 2. Obviously, if I want to do a couple of these, I would go, if I had a second question, I would then put it in list 3 and list 4. So you can see very clearly I could change that by pressing F1 and put it as list 3, and it changes it. Okay, in this case, I just want list 1. You can, oh, and sorry, back up here. When we had scatter, yes, 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 the arrow key tells you you've got more. More, more, more. We're back to, right? So know how to play around with these things. You can go down if you want your marking type to be different. I mean, doesn't make a difference. You got your graph?
I got my graph rainbow.
That's very nice. You can go the color, graph color, I mean, have a look. Anyway, so we exit that and we now press graph 1 and we get our little graphy thing there. And you go, yeah, great, good stuff. But here comes one of the reasons these are worth the 260. So first thing we're going to do is press calc. Now this is saying, would you like to fit a linear graph to that? No, we would not, because that is no way a linear graph. Not really an x squared either, because it's going over. It could be. You could get a cubic, right? But we know we're doing a periodic situation, so we're going to go more, and we're going to choose our sign. So we press F5, and please notice it's actually giving you your A value, your amplitude, your period, not your translation. Why? Because the B is inside the bracket. Okay? You could still write that down. Now, let's play a little bit. You can draw it. So F6, it draws, and this is what we also use for line of best fit. Right? Beautiful, but not much that we do here. It's like, so what? If I wanted to find, tell me what the maximum is, tell me what the minimum is, tell me what it is at 2 o'clock, 3 o'clock, in the middle of September and October, right? What would I do? How can I do that? So we're going to go back, so exit, calc, pick our sign model again, and instead of going to draw, we're going to go to copy. So let's press copy, and what happens? It's gone straight to your graphing function. Now, if I really wanted to keep this graph, I would use my arrow keys and go downstairs and to get a blank one. I'm not really that attached to 3x squared take x, so I'm going to override it. Yeah, and I press EXE. And then I'm back to this, and you go, well, what happened? Nothing. Something. If I go to menu and I go to graph, that equation now is actually in it. But if I try to graph, nothing happens. Why? Because it's not selected. So select it. The thing I love with these latest models is it sets the scale for you. Previous ones, you had to adjust the scale as well, and there it goes. So now we can do the whole G-solve, more, Y-calc, what happens if it was in between February and March, so 2.5. What's the temperature? 26.22 degrees. Okay? So how often do we use these? Not often. But it's nice to know that it's there.